Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in Exercise 12.1 7th Sum. Okay, so here the question is, we need to solve the given linear programming problem graphically. Okay, so 7th one, minimize and maximize z equal to 5x plus 10y, and we can see that subject to constraints also given. Okay, so first what we need to do is using the inequalities. Okay, so for 1 2 3 4 5, so totally 5 inequalities we have. For all the 5 inequalities, we need to find out the common solution space. That common solution space, we call it as feasible region. Okay, so first we need to identify common solution. If there is a no common solution, then for the given z there is a no solution. Okay, if common solution exists, then it will be categorized as a 2. So one will be bounded. Okay, the common solution, if it is like a closed figure, if we get like a polygon, then it is bounded. In case if it is an open figure, then we call it as a unbounded. Okay, if it is bounded, what we need to do is corner points we have to identify, and we have to substitute in the given z. Then the in the given results, I mean whatever results we get, so in that we have to find out what is the minimum value and maximum value. Okay, if it is unbounded, the same process, corner points we have to take it, and we need to substitute in the given z. Then whatever result we get, no, that will be may or may not be maximum and minimum. To confirm that, we have to do with the minimum and maximum outcomes, we have to form a new inequality. Okay, we have to form a new inequality, and then for that new inequality we have to find out the solution space. And for the feasible region and for the solution space of the new inequality, if there is a no common solution space, then we can say whatever maximum value minimum value we get, that will be 100%, we can confirm that is a maximum and minimum value. In case if there is a common solution exists, no, for the new inequality and for the feasible region, then it is not, whatever result we get, that is not maximum and minimum. Okay, so let's find out first common solution space, and we'll check whether it's a bounded or unbounded, then further let's proceed. Okay, so now let me start doing. So the given inequality, first inequality, x plus 2y less than or equal to 120, right? What we need to do is, I'm going to convert this as an equation. Okay, so the line, I'm going to draw it in the graph. Okay, the line of x plus 2y equal to 120, I'm going to draw it in the graph. To draw the line, no, minimum how many points are required? Minimum 2 points are required for us. Okay, if x equal to 0, then corresponding y value, 2y equal to 120. 2 ones are 260 times. So y takes the value 60. If y is 0, then x value will be x plus 2 times of 0 equal to 120. Then x equal to 120. Mm. Now let's draw the graph of x plus 2y equal to 120. And we know that all linear programming problem, by default the last two conditions will be there, that is x comma y greater than or equal to 0. So what does it means? Only we will have a common solution for both x greater than or 0, y greater than or equal to 0, only we have in the first quadrant. So I'm going to give more space for the first quadrant. So I can notice that the first point itself is 0, 60, 120 and all we got. So I would like to take 10 points. Okay, one unit has a 10, I'm going to consider 10, 20, 30. Okay, so first point is 0 comma 60. If x value is 0, okay, where we will have in the y-axis, no, so 0 comma 60, where do you have 0 comma 60? This point is 0 comma 60 point. And the other one 120 comma 0, where do we have here? This point is 120 comma 0. Now on joining the both the points, what we will get? We'll get the line. So this is the line of x plus 2y equal to 120. Okay, this is the line of x plus 2y equal to 120 line. Now after drawing this red line, no, we can notice that the graph is dividing into two portions. Okay, one is above, okay, this one, the other one is below here. Okay, so we need to identify where the solution exists for the given inequality, whether in the above the red line or below the red line we need to identify. So for that, what we can do, no, randomly take one value from this portion. It can be anything, 70 comma 10, 60 comma 20, or 50 comma minus 10, any point in this portion. Okay, 0 comma 0, 10 comma 10, anything. Okay, the easy one, let's take 0 comma 0. I will take it and I am going to substitute in the first inequality. So 0 comma 0, in place of x and in place of y, if we replace 0, no, in this here, so 0 plus 2 times of 0, which is 0. Is it 0 is less than or equal to 120? Is it condition satisfies? Yes, it's true, no? So what we can, 0 is a less than 120. So condition is satisfying. So for the given inequality, we have a solution below this red line. Here, this side we have. Now, same way for the other inequalities also, we have to find out the solution. Then common solution space we need to identify. Okay, now let's go with the next inequality. So to draw the line, no, first we have to convert the given inequality as a equation. So let x plus y equal to 60. Okay, if x is 0, the y value is 60. If y is 0, the x value will be 60. So 0 comma 60 and 60 comma 0. So 0 comma 60 already we have, so same point. And next one 60 comma 0 we have here. So this point is what? 60 comma 0. Now connecting both these 2 points, no, we'll get the line of the next equation. Little more tilting. Mm. Okay, so this yellow line again dividing the graph into two portions. One is above this portion, okay, this side, the other is below. So now we have to identify where actual solution space we have for the given inequality. So let me take same 0 comma 0. We will check whether it's satisfying or not. 0 comma 0, if you substitute, no, then 0 plus 0, which is 0. Is it 0 is greater than or equal to 60? No, then we don't have a solution space this side. Okay, we don't have solution space this side, then obviously we have a solution above this yellow line. Okay, this is the line of x plus y equal to 60. This yellow line is x plus y equal to 60, and for the given inequality x plus y greater than or equal to 60, solution we have this side. Okay, for the next inequality x minus 2y greater than or equal to 60 we have. Now let x minus 2y greater than or equal to, sorry, greater than or equal to 0. Now, sorry, we need to consider as a equation first to draw the line of x minus 2. Then we can identify the solution space. 1 second. Now, if x equal to 0, the corresponding y value. If x equal to 0, then corresponding y value also, what we are getting? Same 0 only we'll get. Okay, then we need, with the 1 point, it's not possible to draw the line because infinite lines will pass through the 1 point. So to get the x minus 2y equal to 0 line, we need one more point as well. So for that, what we can do is, I'll substitute y as a some 10. So I'll take y as a 10. Then x minus 2 times of 10 equal to 0. Then x equal to minus 20. Here you will get minus 20 equal to 0. Then x equal to 20. Okay, if x equal to 0, y also 0. If x equal to 20, the corresponding y value is 10. So 0 comma 0, here we have 0 comma 0 point, here we have a 0 comma 0. The other point is what? 20 comma 10. 20 comma 10, we will have it over here. Okay, now extending. So what I will do is, let me take one more value also. I'll take it like a 60. If y has a 60, I will take. Just using a scale extending also fine. But anyway, y as a 60, if we take the corresponding x value, what we will get? 120 we are getting. Okay, the corresponding x value is what? 120. So 120 comma 60, let's plot it. 120 over here and 60 is here. So this point is, yeah, 120 comma 60 point. Now let's connect all the 3 points no together. Okay, now this blue line dividing the graph into two portions. One is this side above and the other one is below. This side we have. So we need to identify actual solution for the given inequality. For that, let's take any value which is lies this side. So shall I take 50 comma 10? 50 comma 10, whether condition satisfies or not, we will check. So x as a 50, y as a 10. So let me substitute here. X as a 50, y as a 10. Then 50 minus 20, which is 30. Is a 30 greater than or equal to 0? Yes, the condition satisfies. That means we have a solution space below. This side we have. Now you can see all the three. As of now, we have drawn the solution space for the three inequalities. And for all the three, there is a common solution. Overlapping, no, triple shaded portion is the overlapping. So that is the feasible region. Now other two, x comma y greater than or equal to 0. That means what? It's only in the first quadrant. In the first quadrant, wherever all these three is meeting, no. So that is the feasible region. So I will highlight it. So you can notice. So this portion, the only in the first quadrant. In the first quadrant, if you notice this particular portion, the all the three inequality solution space we have. This particular one. So the triple shaded portion, mhm. So this shaded portion is the common solution space for the all the five inequalities actually. Totally five we have. For all the five, this is the feasible region and it is bounded as well. Now what we need to do is we need to take the corner points. So wherever the two lines meets, no. So here you can see yellow line and y equal to 0 line is meeting. And same way here red line and y equal to 0 line is meeting. And here the blue line and yellow line is meeting. So this is also corner point. This is also corner point. So we need to take all the four corner points now. So this corner point is what? 60 comma 0. Okay, so I'll name this as a 60 comma 0, and this corner point 40 comma, with the help of the graph we can notice. So what is this point, particular coordinate point? 40 comma 20. And the next one is 60 comma 30. 60 comma 30. And the other one 120 comma 0. So I'll name this as a B and C, and here this as a D. So we can notice that for the feasible region exists for the given inequalities are subject to constraints. So sorry feasible region exists exists for the given inequalities, and it is bounded. Corner points are corner points are A is 60 comma 0 and B is 40 comma 20 and C is 60 comma 30 and D is 120 comma 0. 4 corner points. Now all these corner points we have to substitute in the given Z. Okay, corner points. Okay, Z equal to, what is the given Z? 5x plus 10y. 5x plus 10y. Okay, first point 60 comma 0. Second one 40 comma 20. 60 comma 30. 120 comma 0. Okay, now all these points we are going to substitute in the Z to get the value of the Z now. 60 comma 0, if we replace, no, 5 times of 60 plus 10 of 0. Okay, what we will get? 300. Okay, 300 plus 0, which is 300. On substituting the first point, we are getting the Z value as a 300. Now let's substitute 40 and 20. So 5 times of 40 plus 10 times of 20. So 200, and here also we are getting 200. So 200 plus 200, which is 400. So here we are getting 400. Now 60 comma 30, let's replace. 300 plus 300. So we are getting 600. Okay, now 120. So 120, 5 times of 120 plus 10 times of 0. 10 times of 0, which is 0. Okay, we are getting 600 for the other one, 120 into 5. So now you can notice that in the question they're asking both the minimum and maximum value. Minimize and maximize the Z. So what is the minimum value here? The least one is 300. Okay, this is the minimum. Okay, and maximum values we can see 600, but we are getting in the 2 points. These two are the maximum. These 2 points are what? This is A, B, C and D, right? Whether C and D is making any straight line is a line segment, let's check. If it is a line segment, no, then all the points in the C, D gives the maximum. Okay, so we'll notice C, D. Yeah, C and D, if you notice 60 comma 30 and 120 comma 0. So not only at these 2 points, the point, whichever point lies in this particular line, no, every point in the CD line gives the maximum. Okay, that is the meaning. So if you are getting more than one maximum or one minimum, just check whether it's forming a line segment or not. If it forms a line segment, that the points, all the points which lies in the line segment gives a maximum result. Okay, so the minimum value of the Z is, therefore, minimum value of Z is 300 at 60 comma 0. Maximum value of Z is 600 at every point in the line segment CD. Okay, so that's all the solution. Thank you for watching and please do subscribe. Thank you.